this video, we're going to talk about how to add two matrices together and how to multiply two matrices together. When we want to add two matrices, we are going to add them by adding the corresponding elements together. If you take the 2 and the 1, the upper left corners of these matrices, and add them together, you will get the upper left corner of the matrix that you get by adding them. So 2 plus 1 is 3, and that'll go in the upper left corner of our new matrix. 1 plus 3 is 4, which will go in the upper right corner. 3 minus 3 is 0, which will go in the lower left corner. That would be negative 3 plus 3. And then 0 plus 8 is 8, which will go in the lower right corner. As another example, we can do the same thing with a much larger matrix. We add all the corresponding entries together, and we'll end up with a large matrix. 4 plus 1 is 5, 3 plus 1 is 4, 4 minus 4 is 0, and so on. As I keep adding these together, you should notice one thing. In order for this to work, the two matrices that I started with had to be the same size. If one of them had an extra column or one of them had an extra row, I wouldn't be able to find a corresponding entry to add to the entries that I have. So one of the stipulations for adding matrices together is that they have to start off the same size. And to talk about size, we really need to have some sort of notion of how big a matrix is. We're going to measure the size of a matrix based on how many rows and columns it has, which hopefully makes sense. And we're going to write it in terms of rows by columns. So this matrix that I have here has 3 rows and 4 columns. So we're going to say this is a 3 by 4 matrix. As another example, this matrix here has 5 rows, 1, 2, 3, 4, 5, and 2 columns. So this is a 5 by 2 matrix. Multiplying matrices takes a lot more work. The easy way to multiply would be to multiply corresponding entries, but it turns out that that doesn't give us the properties that we need. So we're going to start by multiplying a single row by a single column. We multiply the corresponding entries of these. So the 1 times the 2, the 4 times the minus 1, and the negative 2 times the 3. If we multiply those together, what we want to get out of this is a single number. And so we'll add the different results. So 1 times 2 plus 4 times minus 1 plus negative 2 times 3 is what we're going to call multiplying a single row by a single column. So 2 minus 4 minus 6 is negative 8. If we have more than just a single row and column, we need to make sure that the number of columns of the first matrix matches the number of rows of the second matrix. So m by n and n by p, if those n's match, we multiply them together and the result will be m by p, m rows by p columns. I'm going to illustrate this with an example. We're going to take two matrices and multiply them together. We split the first matrix up into rows and the second matrix into columns. To check to see if these matrices can be multiplied, we need to look at the sizes of each and then check the number of columns of the first matrix and the number of rows of the second matrix to make sure they match. So we do that. The first matrix is 3 by 3. The second matrix is 3 by 2. Because the number of columns of the first matrix match the number of rows of the second matrix, we are allowed to multiply these. The resulting matrix is going to be 3 by 2. That is the number of rows of the first by the number of columns of the second. In order to form the entries of this new 3 by 2 matrix, we're going to multiply each row by each column and put that in a particular spot in our new matrix. In the upper left corner, this is going to be in the first row in the first column of our new matrix. We multiply the first row by the first column. We take the first row of the first matrix times the first column of the second matrix. I'll write that here. It's 0, 1, 5, that's my first row, times 4, negative 1, 2, which is my first column. That'll go into the first row and first column spot of the new matrix. It will be 0, minus 1, plus 10, so 9. Will go in my first spot here. To fill in the second spot here, we are looking at the first row and the second column. So we take the first row and the second column of our original two matrices, multiply those together, and that'll fill in this spot. We do that. It's 0 times 1 plus 1 times 1, so we're up to 1, plus 5 times negative 2. So 1 minus 10 is negative 9. And you can check those numbers to make sure they work out. We have 4 more entries to fill in. So we take the second row times the first column. We'll go in the second row in the first column of our new matrix. Negative 12 minus 1 is minus 13, plus 0 is negative 13. This next spot will be negative 3, plus 1 is minus 2, plus 0, so minus 2. Then last row by the first column will go in this spot here. So we get 4 minus 1, so 3, plus 0. So this spot will be 3. And then finally, in the last spot, which will be the second column and the third row, we get 1 plus 1 plus 0. So 2. And this 3 by 2 matrix is the product of the original two matrices that we had. Let's look at another example. This is 2 by 2 and 2 by 2. The resulting matrix will be 2 by 2, and you can multiply it because the 2's match. When all the matrices are the same size, you can always multiply them together. So we're going to end up with a 2 by 2 matrix. Just as in the other example, we are going to split the first matrix up into rows and the second matrix up into columns. And then we multiply each row by each column to get the right spot in the last matrix. So my upper left spot is going to be first row by first column. That'll be 0 plus 12, so 12. My next spot will be the first row by the second column. 2 plus 4 is 6. If we take 0 minus 3, that'll go in the spot here. And then 4 minus 1 will be 3, which will go in the spot here.